Dear colleagues, good afternoon. Can you hear me well?
Yes.
Thank you very much. I'm Vladimir Malayev, and I'm chairing this session on ICT in Cooperation, session 2. I'm glad to welcome you all in this session. I do see that we have the presenters of both papers which are scheduled for the session. The first presenter is Vladimir Sklar, and the second presenter is Leah Bider. So we're going to start in approximately 5 minutes from now, so feel free, grab your coffee, sit comfortable, and enjoy the rest of the session. We'll be waiting a little bit. Perhaps somebody else will join us. Dear colleagues, I'm going to start the session right now. We'll be still welcoming new incoming visitors to join us after the beginning. So before I start, I would like to remind you that the questions could be posed in the virtual session chat box, and then will be asked at the end of the presentation. So we have 2 scheduled presentations today. The first is Business Analysis Learning Perspective in ICT Education by Vladimir Sklar, coming from the National Airspace University, Kharkiv Aviation Institute, Ukraine. And the second is on the fly creation of modeling language jargons, presented by Leah Bider from Stockholm University and Tartu University. So it's my pleasure to announce the first talk by Vladimir Sklar. His topic is Business Analysis Learning Perspective in ICT Education. Vladimir, could you please share your presentation with us?
Yes, good afternoon, everybody. Thank you for your announcement. One moment. I believe you can see.
Not yet. Yeah, now it's on the screen.
Mm-hmm.
Yeah, perfect.
Okay. Thank you. So I'm starting. The main idea of this research was to share our results in implementation of business analysis learning for students who are study some ICT courses. The main motivation was, of course, to implement for our students some hard and soft skills. Hard skills like analytical thinking and problem solving, knowledge of business domain, and appropriate tools and technologies knowledge. And soft skills are related to behavior, communications, and interaction. And to implement these skills, we use case methods and project-based learning. So agenda is the following. Before, I would like to share some basic issues in area of business analysis. After that, I would like to show how did we implement business analysis exercise in one from our course related to functional safety of computer systems. And the last is case study. I will demonstrate students' feedback related with business analysis learning. So there are different understanding what business analysis is. Somebody would like to say it's more about data analysis. Somebody understands it like deep knowledge of business, but I would like to stress on classic business analysis definition from Babok, a guide to the business analysis body of knowledge, and it states business analysis is the practice of enabling change in an enterprise by defining needs and recommending solutions that deliver value to stakeholders. And in accordance with this, very easy, business analyst is any person who performs these tasks. And what is usual business analyst activities in software company? Firstly, so mainly these activities focus on requirements, software requirements, elicitation, and documentation. And first process in software company is pre-sale. It's activity when customer is coming to a company and ask, give some request of proposal or some brief and ask how much would be cost to develop some product, application, or website, or so on. If agreement is signed, then project will start, and the first phase of this project is discovery or scoping phase, when all needed information is collected from the customer, from the market, from audience, from the future user of this product, and then detailed scope for this product can be collected, usually in view of backlog or in some software requirement specification, and then scoping and budget of this project can be specified in details. And after that, it's some routine phase of project, of running project, and business analyst act as team member. In Scrum, he can be product owner or proxy product owner, or maybe just a team member. And the last activity is related with development, some research, and improvement of existing processes. And the main phase for business analytics is, of course, discovery, because it's mainly related to software requirements, collecting, elicitation, and documenting. I discussed specifically this IT project life cycle, so you can see before potential customer comes to us with request of proposal, we implement pre-sale stage. After that, we start active project from discovery stage. After that, we form concept, and after that, we have some increments with delivery, release, and after release support. Agile life cycle or waterfall life cycle could be inside delivery stage, but usually a project is cut to some increments, yes, to provide value to customers and to potential users as soon as possible. And why business analysis is so important? So one of reason is specified here. If we take a cost of some software error fixing on design stage as one, for implementation stage, it will be already multiplied 6.5 times. For testing, it's already 15 times. And for maintenance stage is 100 times more than some error during design stage. So this is a great reason to specify software requirements in as many detail as possible, as many precise as possible, as much precise. Another cutting of this problem is presented here. So you can see what specification, so requirement specification provide more than 40% of all error and system incidents. It's this diagram is related to safety critical systems. So specification is the main root cause of industrial control system incident. After that, modification, after that, design, implementation, operation, and maintenance, and after that, installation and commissioning. And it was about motivation, and the main concept from Babok body business analysis body of knowledge is presented here. So usually we have in business analysis we have deals with 6 main entities: provided solution, context or environment of this solution, value for business and stakeholders. And stakeholders analysis is very important because each stakeholders can have his own point of view for this project. We need to elicitate stakeholders' needs, and we need to control all changes in requirements because they affect very much. And the second concept is some circle in requirements development. So we need to start from high level business requirements, which answer the question why does somebody want it. After that, during design, we clarify stakeholder requirements, which are related to both more specific needs. We provide solution requirements, which answer the question what the customer will receive, and some transaction requirements are about conditions of the solution using. Now about our approach to implement business analysis learning in education process. So we at our department of computer system networks and cybersecurity, we started to do it during master course, functional safety of computer system. So this course is divided into 6 main modules. You can see it's here: introduction, standards, functional safety management, safety and security life cycle, quantitative assessment on functional safety, and techniques and measures of functional safety assurance. And we try to combine to make some superposition of safety learning concept and business analysis concept. So during for safety, for learning safety issues, we focus on such points as certification and licensing, safety and security relation, related terminology, standards requirements, process management, quantitative and qualitative assessment, and technical and organizational measures. And points related to business analysis include fundamentals, description of discovery phase, domain analysis and competitor analysis, business models, some specific exercise like persona, customer journey map, and so on. This is our main subject of learning. So you know what safety critical system are a bit different from generic information technology based system, because they have deals with real world objects. So I show here architecture at the left corner, architecture of typical IoT system, which based on 4 layers: device, network, service, and application. And here is industrial control system architecture, which includes field sensor and actuators devices. After that, level of programmable logical controller. After that, data acquisition system and control system. And after that, level of control of enterprise. And convergation of these two technology give us today industrial Internet of Things systems, which include some cloud, which with emulated hardware and application software installed in the cloud, and to this cloud could be connected some remote clients, mobile clients, and as named remote site with the same architecture like for industrial control systems. Requirements to the systems are specified in some classes, and they are going from requirement of safety and security standards. For safety standards, in safety standards, safety integrity levels are specified, and in security standards, we have security levels. And some requirements from safety and security standards are pretty close each other, so we need to consider this like one big set of safety and security requirements. So firstly, we have requirements to management of process. It can be functional safety management or security management in accordance with ISO 27000 series of standards. After that, we have requirements to safety and security life cycle. In fact, this is one life cycle which is based on the combined set of safety and security requirements. And after that, we need to implement countermeasure against failures. And these failures can be random, caused by physical hardware failures, and these failures can be system because some mistakes during design system or software. And of course, we have some attack, and attack resilience should be also specified and implemented in such kind of systems. Now I'm going to discuss how we implement business analysis exercises to our education. So here are the main exercises which we provide for learning and for performance for our students. So firstly, this is information architecture of software product. It can be website or web application or mobile application. And during this exercise, students need to make graphical representation of a product as a set of screens, and it has some value for the future IT professionals, because they will be able to describe software product in clear conventional graphical notation. The next exercise is business model canvas. Usually it's table which represent some key business issues like cost structure, business partners, channels of distribution, and so on. Competitor analysis, it's easy. It's comparing of product and service with other services on the market. Domain analysis, it means it can be industrial or program domain, during which we need to discover trends and best practices in this domain. Persona methods create a portrait or typical customers or of some ideal customers which will use our product. Customer journey map provide visual story of customer interactions with our product. And backlog is in fact requirement specification which provide us requirements by some systematic way When we study feedback from our students, we use these samples. During 4 years, we prepared 40 graduated masters in area of cyber security. Not a big sample, of course, not a huge, but we can have some finding and insights here. And a structure of our hypothesis include level of satisfaction, preference, some student preference, feedback, how do students understand theory or practical exercises, and their motivation. And some results are presented here. So this metrics we measure in accordance with 5 degrees scale, and you can see we learn student satisfaction level for the course learning, how this new learning format is better than traditional without business analysis learning. We measure students' understandability of lecture materials and project materials and their motivation of this learning, and you can see it's everything is about or even higher than 4 value accepted understandability of the project materials. Maybe we need to work for this point. And you can see exam degree is also quite high. Maybe it's because motivation, and you can see some changing here in 2080, probably it was because not high level of this group and studying. Also, we collected positive feedback of this course, and we tried to take from students some points for improvement. And as a result, we built a business analysis learning framework, which include principles of case method implementation, because everything what students gave during this course study was based on the case methods, and we implement project-based learning principles. And of course, also in this framework, we included special courses development and improvement. We monitor learning effectiveness, and I shared some our result. Of course, we designed business analysis exercises and collect our case study. So conclusion are like the following. We need to implement pedagogic innovations in our learning process because it can highly motivate students. And business analysis is a sufficient knowledge domain for the future software engineer because it supports positive business change on the base of needs and requirements, elicitations. And we obtained these case study results for massive online open course safety and security of control systems, included in sample 40 master students, and checked the main issues with increasing and or decreasing quality of learning. And also I presented you a practical business analysis framework, which based on the project-based learning and case method principle. And that's all. Thank you very much for your attention.
Thank you very much for your presentation. We've got already some questions here. The first is by Vitaly Kobets. He asks if you considered a strategy of IT architecture and resources necessary for the implementation of this strategy or requirement. Did you have any KPI to measure the quality of the developed IT architecture?
Okay, thank you for this question, but I think this question is more related to the real software project. Yes, IT architecture is essential part, of course, of software project, but it depends from company to company. Some companies not push business analyst for building of IT architecture. Usually they have some solution architect or technical officers or development team leads who build IT architecture. So in our exercise, we did not have this issue. So we concentrated mainly on how to say on the specification of business and user requirements, not technical requirements to the solution.
Okay, thank you very much. Everyone is welcome to type in the questions, if any, to the chat box. Vitaly Kobes is happy. So while we're waiting for more questions, I have my own. The reason to ask is that the topical track of the conference we are in is about the collaboration between industry and academia in ICT. I did not really notice that in your work you mentioned any collaborators from industry on this course. Did you have some?
Yes, I do. So I'm personally an example of collaboration because I'm working firstly for national university and secondly I work for some software company Artkai. It's not a big company, less than 100 people. So all my experience I put to the university from in the industry. So I provide to students the real project cases and I share with them my experience in business analysis.
Okay, thank you. So the project-based learning is based on your industrial experience. Okay.
Right.
One more question about the massiveness of your online course. You mentioned that it was around 40 people, 40 subjects sampled in 4 years. Is it really a massive online course?
Yes. We started to push this course like online. It was like some experimental, but our reality shows us it was very appropriate experiments because in the last years we used many finding and many insight from this our experience.
Okay, thank you very much. Do we have more questions, please? Not at the moment. Then I thank you for a very nice presentation.
Thank you very much for your attention and for your questions.
It's my pleasure to announce our second speaker, who is Ilya Baida. Ilya is going to talk about on the fly creation of modeling language jargons. Ilya?
Yes.
Could you please share your presentation with us?
Yes. I will try. Just a moment. Okay, I'll start with this one.
Yeah, it's on screen.
Do you see something?
Yeah, I would suggest that you switch it to the presentation mode before sharing. First open in the presentation mode, then share the presentation mode. Because otherwise, we would not see a presentation in it properly. Yeah, excellent. Ilya, please unmute your micro. The red button, microphone crossed. Please unmute, because we can't hear you. Вы можете его разместить?
Да, это лучше. Ну, вон там красная кнопка, он видит.
Oh,
Yeah, exactly. Thank you.
the question is if you see my
Your
screen.
presentation, not yeah, but not in the right mode, not in the right, not in the presentation.
Okay. Now.
Yeah, perfect.
Okay, good. Sorry for disturbances. I'm not accustomed to this tool. Okay, I will present a collaborative work on creating modeling languages jargons. I'm Ilya Vider, and I'm retired now, but still work for two universities, one in Stockholm and one in Tartu, Estonia. And we have two collaborators. It's Erik Perjuns, also from Stockholm University, and Dominic, who works for Technical University of Wien, and he was the main force of implementing the ideas. So I start with the screen. We've got an advice from organizers to present in certain way, motivate your audience to engage with research result, actively participate in discussion, read paper, and use it. And we need to create an appetizer. So most of presentation will be not slides, will be a live demo, but there are some slides that I will show. And I start with this one. It summarizes the goal of research, and it's find general principle of creating jargons in modeling languages that can be implemented through modeling tools. So there are some terms here I need to explain. And modeling language in this work we treat as visual language to present organizational activities, and there are a lot of such languages like UML, BPMN, IDF0, Archimate, and FEM. FEM is our tool. I will go through it a bit later. And modeling 2 is an application that supports drawing diagrams and models using a modeling language. And now we come to jargon, and we have two definitions, one from Oxford Dictionary and the other from Cambridge. It's words or expressions that are used by a particular profession or group, and can be difficult for others to understand, but still they are words in normal language, and it's more or less the same in Cambridge. And the next question, why do we need jargons for modeling languages? And we talk about universal languages that can be used in various projects and for completely different purposes. And dependent on the purpose and also on who are the people working with this language, they need to highlight certain things and don't highlight other things. And usually there are not one model, but a lot of diagrams that are connected to each other that are needed. And they might need to arrange it in a certain way. And it can differ, the needs can differ from project to project. So how to solve this diversity? There are several ways. One way is each time you need something new, you enrich language, and the language will grow and grow. And we have this effect somehow in BPMN, which started as a small language understandable or meant to be understandable for business people, and have grown to the extent that nobody understands or use it in full, especially not business people. And the same trend I see in Archimate, which is enterprise architecture language. So it's one way. Another way, a lower extension, and this extension can be tuned in a tool that support, but they will require skilled professional to make this extension, and then people in the project who are not technical can use it. And UML has this kind of extension, for example. And the third one, which we try to implement, is give the people, modelers, mean to create jargons on the fly. So they don't need any specialists, they can create a jargon without changing the tool. But we need some means for it in the tool. Okay, this is just a background and motivation. This problem was discovered in a specific settings. We were developing a tool for building diagram according to ideas of fractal enterprise model. We have a picture of it. I will go through it in a demo, so you don't need to understand it right now. And to solve the problem in this toolkit, we implemented some means and programmed it. And then we looked at these means and decided they are universal. They are not specific for fractal enterprise model or for our tool. So we decided to generalize them, and it resulted in writing of this picture. FEM toolkit was created based on ADO-XX environment. So there are other tools that are built with this environment, and they can almost easily to implement the same things as we implemented. Okay, and what are these means? Right now we have 3 means that can be considered general. It's subclassing, ghosting, and nesting. So what I will do now, I will leave the slides and come back with them in the end, and switch to demonstrating. Okay, I am moving. Now I need to do something to see my screen. Okay. Okay, here. Do you see it clear?
Yeah, it's okay.
It's okay?
It's okay.
I will try to make it like this.
Could be bigger.
I need to make it bigger. Just a moment. No, it's vice versa. I need to make it. Is it okay?
Yeah, it's readable. Thank you.
Yeah. Okay, good. So this is a tool with which we worked. And I start with explaining this diagram. and some basics about fractal enterprise model. The main elements are processes, which are ovals, and assets, which are rectangles. So if we have a process, it's not a process instance, it's a process type. To run instances, we need some assets that are engaged in this process. And for example, for manufacturing, that is top process, we need workers, they are not here. We need customers that places orders. And we need some sophisticated manufacturing equipment. So it's three assets. There can be much more, and there are much more, but we are interested right now in these three assets. And they play a role, and customer is a beneficiary of this process, get some value. Manufacturing orders, we need all the time a stock of orders, and stock is an asset which is depleted by instances here. Each time we run a manufacturing batch, some order disappears, so we need constantly to fill it up. Customers can stay and place more and more orders. If we have this asset, which is a manufacturing equipment, it plays the role of technical and informational infrastructure, and it is reused in many batches, in many instances of this process. Then we have the second level. When we look, okay, we have assets, we need to maintain them on a certain level, both qualitative and quantitative. So we need some number of customers, we need to fill the stock, we need to have our manufacturing equipment in good order. And for this, supporting processes, the name here depends on what it supports, but the role is here. So sales acquire and maintain customers, and at the same time acquire new orders. Purchasing equipment, add equipment here, and it should be serviced, and it's maintain role of this process. There can be another process which remove old equipment that cannot be used anymore. So there are three types of service of supporting processes: acquire, maintain, and retire. And after that, we can go and look at the next level. These processes also need assets. And for example, for purchasing, we need a partner equipment vendor. For servicing, we might need a contract with vendor who provide spare parts and maybe technicians. And in this case, a company created special diagnostic and deductive software, which is used to see whether equipment needs service or the service can be postponed. And for this, they employed software people, software processes, and driven by people. So the idea that it's called fractal is because we have patterns that alternate from process to a set of asset, and from asset to a set of process, and recursively it's going down. There are two more elements to represent environment. This is like a market from which you draw new customers, and there can be other actors, external actors, which draw from the same or add to the same. So this is a basic of fractal model, and here we have a diagram. And now we come to the three means of creating a jargon: subclassing, ghosting, and nestling. So we start with subclassing. This diagram was drawn to innovate the business of this manufacturer. Actually, they put a lot of efforts in diagnostic software, and it worked okay for the company, but they decided maybe we can sell it to other manufacturers who use the same kind of equipment. This includes their competitors as well. So they need to see which processes and assets they can reuse in a new business and mark them in some way. So how we can do it? I can save it. I change something probably. To do it, I create a new firm. Subclassing is a new type of model, and we can say classification something. Classes. Okay. It doesn't change, but it doesn't matter. I can change it, rename classes. Okay, and here we have the same elements, but they serve for different purpose. So I just drop it and put it here and give it a name like primary process. And I can change. I can choose a color for it. I can leave the color as it is. I can drop another one. And, it's too many. I'm trying to be too quick. I need only one. Okay, I can call it alternative for primary. Okay, and I can give it another color. I can take yellow. Could be good. I can take this one. Okay, and I can put yellow here also. Okay, so we have two. Then we can think of putting one more class and say that it is reusable. We're using a new business, and we can take, say, blue. Okay, and we can take this one as well and say it's also reusable, but it's reusable asset. Okay, what is color here? I think this color is better. The other one is too dark. So I leave it like this, and I change this one. Okay. So we created 4 classes, 3 classes for process and 1 for asset. I save this form and I go back to manufacturing and say, okay, this one is primary process currently. So we have it. This one can be alternative for primary, and we will get another color. And this process can be reused. This too. And this can be reused. And this can be also reused. Okay, so we introduce some classification for a particular purpose. This is for purpose of developing a new business, and we marked our diagram with this classification. And this create the first mean is subclassing. It's not dependent on FEM. The idea is project can create any classification they want. They can classify, for example, assets as being tangible, intangible, and so on. So this is the first. And the next one is ghosting. Ghosting is having the same element in many places and being able to navigate. The question is, do I need to finish in time, or we can have more time?
Well, there are two aspects in my answer. The first is giving you more time would be not really fair.
Okay.
And the second aspect is that we have 2 presentations for 3 time slots. So please use a little bit more.
Okay. I just go quicker through other 2. If we we need to repeat this element once more. We choose this element and go to create ghost for selected, and we placed it here. So we can have ghost and we can connect it in another way over here. And we can go from ghost to the original, and we can find all occurrences, for example, in current model. So we have duplication, and we can find these elements, and it can be used in the same model, or it can be used in a different model. So we can use it in a different model. For example, we take sales and we create a new model, and we go take this sales and create ghost from selected and put it over here. So we have a new model. And the third one, nest link, we can expand this element by defining it's a group and putting something in it, and it can be a new process. Like and pressing the sales for existing customers to existing customers, and another one sales to new customers. And this is nest link. So the meaning of it can be different. Here's 2 different processes. We can connect them also with other elements, or sometimes it is is a decomposition where they are connected. This is two types of sales. Another could be to break sales into sub-processes. So this is the third one, and I can go back to my slide and finish it. So again, I'm going too soon. So so this is conclusion what we have done, and thank you. And you can have, if you were interested in FAM and a toolkit, there is a lot of materials over there. So it's fine with me. I'm stopping sharing. If there will be questions that I need to answer by showing, I will start again.
Okay, thank you very much. To have a mic, yes, I do. So we have a question from Vladimir, who asks to provide more examples of jargons, but for a different language, for UML, for instance. Can you do that?
What do you mean? If we can use the same principles in UML?
Yeah, you said that
Yes.
the means
Yeah.
you
Yeah,
described are not language dependent. You
Yeah,
use them as
yeah.
one of the instances for languages. Can you?
Yes. For example, classification could be easily implemented for ML if you want to differentiate your classes according to your project needs. Actually, you can do it in the same way. Just your tool need to support it. So you don't put background colors in ad hoc manner. You have classes and you just decide this UML class belong to this class of classification. The same with ghosting. If you want several diagrams and you want to have an element from one diagram to another, you can create a ghost of this element. In our implementation, it has special shape with an arrow in the upper corner and can be reused in UML as well. The same concerning, maybe the third one is a bit specific for some languages. For some languages, it may not be appropriate with nestling, because nestling doesn't have exact semantic. It's just a way of viewing, and the project needs to define semantics themselves. What does it mean when you put things inside? But in principle, you can use nestling in UML. You can do it eBPMN, especially, for example, to show context, like databases, that it is the same database, not another database, in a different diagram. If we are talking about not about one BPMN diagram, but a repository where there are many diagrams and different processes reuse the same data sources or the same system or the same people. Actually, it's impossible to understand it in current repository. But if we implement this ghosting, it would be possible to not invent a new element, but say this database that is in this diagram is the same as in that diagram, and have a navigation answering a question where this database is used, and then you get a lot of diagram, and you get this database highlighted in all of them. So it's a way like, if we go back to what is jargon in natural language, we can say that classification is creating new words. Classes are new words, reusable or primary or whatever. It can be tangible, intangible, whatever. It's a new word which doesn't exist in the language. Ghosting is a style of creating text from sentences, because different diagrams can be compared with different sentences, and you can create, you can connect them. So it's a way of have definite articles, the or pronouns and so on. So it's a comparison of styles. So that's why even ghosting we consider jargon, and we consider nestling also a jargon. But the meaning of it can be different, and the style can be different. We just provide means for creating it.
Thank you. More questions? I have a question.
Yeah.
Well, as far as I understood, this work in language jargons has been undertaken just to please your industrial partners in industrial projects. Let them work with the easier things than normal
Yes.
tools provide them.
Yes, it's like.
So now I go to the question.
Yeah.
The question is, did you have any result in usability in acceptance testing?
We haven't done any formal testing, but people were using it, and we have some people in professional projects. Not many. It's not like very spread too right now. We are trying to spread it, and we have some master's thesis projects where students worked in the field and presented result to the organization where they worked. So they tested it and they showed it, and even could create much interest from organizations' own system, or not system, business architect. These features were used widely, because without them it's difficult, because otherwise all elements like see the same, and if you use colors, you need to use them in some systematic ways, and you get it from subclassing. And if you need to break diagrams to more understandable parts, you need ghosting, otherwise you don't connect it. So no formal acceptance testing has been done so far. It's a work in progress, and the main thing right now is for us to attract enough people that work with these tools, hopefully without us, maybe with some help from us, but without us. And we haven't achieved it right now. But the idea is that these features are needed to make tool usable.
Yeah, thank you very much. Well, as a practical knowledge engineer, I do use all the three means you listed today in many projects. Don't calling them ghosting or self-plagiarizing or whatever, but yeah, you're right. Intuitively, those things are very useful. And of course, it is always a matter of a critical mass to find the early adopters for the things we're developing.
Yeah.
So I'm wishing good luck to you on that way.
Yeah, thank you.
And if there are no more questions, then we have completed our agenda. Thank you for submitting. Thank you for coming with your interesting presentations. And looking forward to meeting you in the next instance of ICT with user acceptance testing.
Yeah, it's we need to have enough subject to analyze.
Yeah, of course, but you may start with the smaller sizes, like your colleague from Kharkiv reported today. Well, let's put smaller and realistic objectives in front of us, and go ahead step by step.
Yeah, sure, will do.
Yeah, thank you very much,
Thank you.
and enjoy the rest of the day.
Yeah, thank you. Bye.
Goodbye.